one, we're going to evaluate the improper integral or state that it diverges from negative infinity to 0. We have z times e to the power of 2z times dz. It's an improper integral with infinite integration limits. So we're going to use these examples here. We are continuous on negative infinity to 0. So I'm going to use this limit here to help me evaluate it. Before I get started, let's go ahead and integrate just this. So I'm going to use tabular integration. It's a shortcut. So you write down your z and you take the derivatives till you get to 0. And for e to the power of 2z, you take all the integrals. So you copy down z, derivative of z is 1, derivative of 1 is 0. And then for e to the power of 2z, you integrate it. So that's going to be, copy down the function first, and then you integrate. So that's going to be 1/2 e to the 2z power. And then you match up to the 0. That's going to be 1/4 e to the 2z power. Then you draw these diagonals. This is going to be plus, minus. So what we're going to do is get this is going to equal 1/2 z e to the power of 2z. And then you take your minus here, minus 1/4 e to the power of 2z. So that's the integration part. Now let's look at our limit. We're going to rewrite this as the limit. And as they have a here, I'll just use t as t approaches negative infinity and substitute my negative infinity for t to 0. And our function is going to be z times e to the power of 2z dz. All right. So again, we already integrated this. So now we're going to write this as the limit as t approaches negative infinity. And we already did that. So let's write that in. 1/2 z e to the 2z power minus 1/4 e to the power of 2z. And we're evaluating it from 0 to t. All right. So what we get is the limit as t approaches negative infinity. And we're going to use 0 first. So when you plug in 0, this first term we get 0 minus 2 to the 0 power is 1. So we're just going to get negative 1/4 here. So that's the first part. Now let's do the t part. So then we're going to get minus 1/2 and substitute in the t for the z. All right. Now, when you take the limit of this part, you're just going to get negative 1/4. For this part, when you plug in negative infinity, what's going to happen there is you're going to get, let me erase this. Just remember e to negative 2 times negative infinity. When you're plugging in, well, that's positive 2. That's going to be 1 divided by e to the infinity. So basically, when you put this in the denominator, this is going to go to 0 because the denominator is going to grow faster than the numerator. So this is going to be minus 0. Same thing's going to happen with this. When you substitute in a very large negative exponent here, this is going to go in the denominator. So your denominator is going to grow faster than the numerator. So that's going to be 0. So basically our answer is just going to be negative 1/4. And that means it's convergent. So I'll just write convergent here. So I don't have to move over. All right, that's it. Thank you. Have a nice day. Bye-bye.